Two runners on a track. If there's a loop, they must collide. But why must? Pattern 10 of 10 in the NBX STUDIO dojo. Fast and slow pointers. Two runners at different speeds, and the last pattern in the set. Cycle, or loop, is the obvious one. Linked list almost any question about one. Find the middle in a single pass. Circular, or does it repeat? And a constraint you'll see written explicitly. Order one space. No extra memory allowed. If extra memory is fine, a visited set is simpler, and you should say so. That memory constraint is usually the real signal, because it's the interviewer quietly ruling out the easy answer. Picture a running track where you can't see the whole shape. For nodes, 1, 2, 3, 4, and 4 quietly points back to 2, so the last stretch is a loop rather than a finish line. Two runners set off from the same place. The tortoise takes one step at a time. The hare takes two. If the track ends, the hare falls off the end first, and we know there's no loop. If it doesn't end, something else happens, and that something is the whole pattern. Slow equals fast equals head puts both runners on node 1. Python lets you assign two names at once like that, and both now point at the same first node. No extra memory has been allocated at all. Not a set, not a list, just two references, which is the entire reason this pattern exists. While fast exists and fast.next exists, keep running. That double check is the guard. If either is missing, we've reached the end of the track, so there was no loop. Slow moves to node 2. Fast moves twice to node 3. The gap between them is one node now, where a moment ago it was 0. Slow moves to node 3. Fast moves 2 again. Node 3 to node 4, and then 4 points back to 2, so the hare lands on node 2. It has been round the bend, and it's now sitting behind the tortoise. The gap is 2. On a track with no loop, the hare would have fallen off by now, and instead it's lapping. Straight from the dojo, and this is the good one. The hare is inside the cycle, behind the tortoise. Will they ever land on the same node? No, the hare is simply too fast. Yes, because the hare gains one position per round, so they must meet. Or only if the loop happens to be an even length. Have a think and pause the video if you like a moment. Ready? Yes, and it isn't luck. Each round the hare moves 2 and the tortoise moves 1, so the distance between them closes by exactly 1, every single round. This is worth being able to say out loud because interviewers ask for it. Once both runners are inside the loop, think about the distance from the hare to the tortoise, measured forwards around the loop. Each round the hare covers 2 and the tortoise covers 1, so that distance shrinks by exactly 1 every round. A quantity that decreases by 1 and can't go below 0 has to reach 0. When it does, both runners are on the same node. It can never jump past, because closing by 1 at a time cannot skip a value. Slow steps to node 4. Fast goes 2. Node 2 to node 3, then 3 to 4, so it lands on node 4 as well. Slow equals fast, so we return true. There's a cycle. One pass, no extra memory, and no list of visited nodes anywhere. Now take the loop away and run exactly the same race. 5 nodes in a straight line. 1, 2, 3, 4, 5, and a proper ending this time. The question changes completely. Find the middle node in a single pass, without counting the list first, and without storing it anywhere. Look at the code, and notice what is different. Almost nothing is. Both start on node 1. Tortoise to node 2, hare to node 3. Round again. Tortoise to node 3, and the hare to node 5. Fast next is now empty, so the loop stops, and the tortoise is standing on node 3. That is the middle of 5. And it falls out for free. The hare covered twice the ground in the same number of rounds, so wherever the hare finishes, the tortoise is exactly halfway there. You never counted anything. One more from the dojo, and this one catches people out. That list had 5 nodes, an odd number, so the middle was obvious. Run the very same loop on a list of 6. Where does the tortoise stop? On node 3, the first of the 2 middles. Or on node 4, the second one. Have a think and pause the video if you would like a moment. Ready? Node 4, the second middle. With an even length, the hare runs off the end 1 round later than you expect, and the tortoise takes 1 more step with it. If a problem wants the first middle instead, you start the hare 1 node ahead. Last one, and it is the question interviewers actually ask. You know there is a loop. Now find the node where it starts. Here is a track where 1 and 2 are the straight part, and 3, 4, and 5 are the loop, so node 3 is the entrance we are looking for. Run the usual race until they meet. Then do something that looks like nonsense. Send the tortoise back to the start. Now walk them both at one step each, the hare included. The tortoise leaves node 1, and the hare moves 1 along inside the loop. Step again, and they land together on node 3, which is exactly the entrance. Return slow. The loop starts at node 3. The reason is a short piece of arithmetic. The distance from the head to the entrance turns out to equal the distance from the meeting point back round to the entrance. Equal distances equal speeds, so they arrive at the same moment. You do not need to derive that in the room, but you should be able to say that sentence. Step back and look at what one loop just did for you. With a cycle, they collide, and that tells you the loop exists. With no cycle, the hare runs out of track and the tortoise is left on the middle. Restart the tortoise at the head after they meet, walk both at one speed, and they land on the entrance to the loop. And if you start the hare k nodes ahead instead of together, the gap stays k forever, which hands you the kth node from the end. For different interview questions, the same 2 pointers and the same 8 lines. For to go and do, linked list cycle is the one we just wrote. Middle of the linked list is the same loop with a different ending. Linked list cycle 2 asks where the loop begins. And happy number is the same algorithm on numbers instead of nodes, which is the one that proves you actually understood it. 3 things to take with you. The signal is a cycle, a middle, or a demand for constant space. The move is 2 pointers at different speeds from the same start. And the reason it works is that the gap closes by 1 per round, so a meeting is forced. That's all 10 patterns. Next comes the part that actually matters in an interview, taking an unseen problem and deciding which of these to reach for. Go and do linked list cycle first.